n be any real whole number. For example, n equals 7. Start by creating a descending order of numbers from n. Now we can calculate the sum of the remainders when each number in the series is divided by m. Let m equal to 3. The remainder is as follows. The set of remainder y is 1 to 0, 1 to 0, 1, which add up to 7. Notice that elements 1 to 0 repeat forming the cycle. When generalizing this concept, in the cycle, the remainders are 1, 2, 3, m minus 1, and 0. The sum of one cycle is sum of integers 1 to m minus 1. The sum of one cycle is as follows from the above formula. To find how many cycles fit, divide n by m from the above example, which comes to n equal to 2 cycles. Multiply this by sum of one cycle. It is 2 into 3 equal to 6. Add the remaining reminders by this equation. Adding all together gives us 7. By following these steps, we can calculate the remainder, sum of remainders. Thank you.
Let's learn how to solve the pairwise sum and divide problem using the example provided. We were given the case with the array a equal 1, 2, 3. As you can see, calculate the value for each pair and sum the result. The first step is find all pairs. First, as you can see, that is find the pairs. Step 2 is apply formula for each pairs. For the example, we apply the first pair in this, and the second pair is this, and third pair is this. Step 3 is sum up the result. We calculate sum up the result like this. That is the final answer for the test. This method works systematically for the you given. Practice this and you will solve this problem is. Thank you.
I will be talk about the question 3, power calculations, which is about finding the last two digits of special sum, where we need to calculate the two powers of numbers from 1 to k. But instead of dealing with very large number, we use a trick called modular arithmetic. This lets us only focus on the remainder when dividing by 100. For each number, we calculate its power and take the remainder when dividing by 100. Then we add up all those remainders. Finally, we take the total sum and find its remainder when divided by 100. This gives us the last two digits. For an example, you can see the screen. This is the first example and second example, third example. So we can calculate this way to the number and take a powers of this number. Thank you.
The scalar products. In this problem, we want to generate a sequence formatting vectors and calculating unique residues from the vector products modular. Let's take the C is equal to 4, M is equal to 5, N is equal to 3. After that, we generate a sequence using this formula. After that, we get the final sequence is this. After we want to form vectors v1, v2, v3, and after that we calculate the scalar product of using these vectors. After that we calculate the residues modulo. 8.5 means 8 divided by 5, and after that we get the remainder is 3. After that we calculate the distinct residues. In this, we want to remove the duplicate ones and we get the 3 and 4. After that, we counted the number of distinct residues is 2.
For solving the K and series problem, we have to know about these three formulas. Now consider an example. Let n equal 5 and k equal 3. For this type of problem, we have to use this formula. Next, we have to do is substitute into the formula. N equal 5 and k equal 3. After all the calculations, we get Sn equal 225. Finally, we have to find Sn mod 10 to the power 9 plus 7. Since 10 to the power 9 plus 7 is large value than 225, so we get Sn mod 10 to the power 9 plus 7 equal 225.
I'm going to explain about 11th problem. Imagine we have two matrices One is like a tic-tac-toe grid filled with numbers, and other one is clean grid called the working matrix. We aim to follow the series of step to transform these matrix based on given numbers. For the example, if t is equal to 4, we subtract 2 to get 2, which tells us how many times we apply this process. The process involves multiplying rows from first matrix by columns. From the second, adding the results and replacing the grid values. If a number becomes too big, we can divide it by 10 to the power 9 plus 7 and keep reminder. It's like using calculator that only shows up 9 digits. After repeating this process for the given times, the numbers in the final grid are sums up to get our answer. For t equal to 4, after the calculation, the final matrix filled with numbers and adding them gives result. This teaches modular arithmetics and matrix operators.
The problem that we are focusing on is the problem of circular summation. The children are sitting in a circular manner with numbers assigned to them. The variables that we should consider are L, number of children, M, number of rounds, AI, the number that the child possesses, I, position counted from the clockwise direction. We have to assume I is equal to 0 at the starting point. The number AI is modified in a way that the neighboring numbers are added to the existing number. For an example, if the numbers 2, 4, 5 are present in a clockwise manner, 5 will be modified to 11, which is 5 plus 6. The game has to be played until the number of rounds are lesser than the number of children. Once they are equated, the game stops. We have to consider all possible outputs by considering all starting points. So 3 children would give us 9 possible rounds.
Now I am going to explain about problem 8, counting equation. We begin by representing the system as a matrix equation Ax equal b, where A is the matrix of coefficient x, the vector of variable, and b the resultant vector. The number of solution is calculated using the formula Pn minus rank A. To find the rank, we use d equal n minus log p s. This value indicates the rank of matrix A. If specific entries of A are determined to be 0, the number of free variable adjusted to n minus z. We calculate configuration using total ways equal p power m minus dn minus z. Let's look at example. Ax by ax plus by is equal n, where a, b, x, and y are integers. Assume n equal 5, a equal 2, and b equal 3. We iterate the possible value of x, ensuring n minus ax is divisible by b. For this example, we find this valid solution. Thank you.
Hello everyone, let's solve the SOR of problem. You have to understand the input. The problem is start with 2 input n and q. For an example, is if n is equal to 3, we create an array A as counting down to n to 1. For each query, you will also receive 3 ingredients K, P, and R, breaking down the queries. Now each query goal to compare to a culminated result for KPR sum. Start with sum is equal to 0. If P is equal to R, we immediately return 0 for this query. Otherwise, we process every element within the range of P and R, calculating the SOR value. Inside the range of P and R, we loop through each element I and pair it with every J. SOR AI and SOR AJ. Then SOR this result with K. Add all those values to the sum. Finally, take the module of sum with a 10 to the power 9 plus 7 to ensure the result don't overflow. Then go to the percentage and process. Thank you.
Partial fraction decomposition is a useful technique in simplifying series for evaluation. The given term is expressed as a sum of partial fractions, which makes it easier to expand and simplify a series. When substituting this decomposition, the series takes a form that highlights the telescoping effect. In this effect, most intermediate terms cancel out, leaving only the first and last term. This simplification significantly reduces the complexity of calculating the series sum. Finally, evaluating the limit as the remaining terms approach infinity. The result of series is calculated to be exactly this method
demonstrates the power of partial fraction and telescoping in handling infinite series efficiently.